Okay, it's 5 o'clock. My name is Henri Picciotto. I'm retired from the classroom. I was a teacher for 42 years, kindergarten to calculus. And now I just think and talk about math education, but I'm no longer teaching kids. You can, there's a ton of links about the stuff I'm going to talk about on my website, which is matheducationpage.org. And if you go there, you'll find a link to my talks, and in there are links to everything I'm going to talk about today. This is what my topic is. It's a fact, and everybody knows it. Students learn new math ideas at different rates. Some kids pick it up quickly, some kids not so much. It's not always the same kid with the same topic, but it's a typical situation all of us have to deal with as math teachers. So what can we do about that? So there are three standard responses to that fact. One is tracking. You separate kids based on some criterion into a regular class and a remedial class and an honors class and so on. And there's anywhere from 2 to 3 or even more different tracks. This image is completely misleading because, in fact, the tracks diverge. They are not parallel. And if you're in the top track, not a big problem, but if you're in a bottom track, you are falling further and further behind. NCTM, in their new document, Catalyzing Change, propose detracking and putting an end to what they call dead-end classes. So anyways, that's one solution. You separate the kids. One problem with that is that within each class, even when you're tracking, within each class, you have a range of kids. So it doesn't solve the problem. Another approach is acceleration. You figure, well, these kids learn quickly, so let's have them move even as quickly as possible, and so you get the result of Algebra 1 used to be a 9th grade class, then it became an 8th grade class, then it became a 7th grade class for supposedly fast students, and there's some validity to that, but not so much. And beyond 1 year acceleration, it ends up for many kids being counterproductive. So I have these two images, racing versus sort of going for depth, and racing in the long run doesn't pay. Anyways, third approach is currently called differentiation. When I was a beginning teacher, they called that individualization. And the idea is that different kids will get different assignments. And so problem with that approach is it's a lot of work for the teacher. It's already hard enough to teach the classes we're teaching. But if each class has to become multiple classes because we are differentiating, it's a lot of work, and some students often complain, well, why do I have to do more stuff? And it undermines the idea of the class as a community of learners. So, I think that there's some validity to all those approaches probably, but not as much as is widely believed. And in any case, classes are going to be, as soon as you have a few kids, the class is heterogeneous. So I'm going to present some ideas on how to address the fact that kids learn at different rates. First, let me describe the principles sort of underlying my ideas. First principle, alliance with the strongest students, support for the weakest students. And I know that it's fashionable to say there's no such thing as stronger and weaker students. I don't agree with that. You know, we all know there are stronger and weaker students. They're strong in different ways. Some kids are better visually, some kids are better with numbers and so on, but they're not all the same. Each kid is different. And we need both to support the weaker students and to support the stronger students. And it's a mistake to focus on one or the other at the exclusion, or focus on one at the exclusion of the other. Strong students are really important. So they're important politically, because if you're not challenging them and getting them interested and teaching them a lot of math, you're going to hear about it because their parents are active, you can't win unless you challenge your strong students. It's also important philosophically to pay attention to them, because that's part of our job. You know, they're all kids we're teaching. We're responsible for their learning just as well as everybody else. And moreover, many of them will be the math teachers of the next generation, and the scientists and the mathematicians and the engineers and the statisticians and so on. So we need, we need to pay close attention to them. And finally, they're crucial pedagogically because they're your main ally in the classroom. They're the ones who can help you, they can be kind of an engine that helps drive the class forward. So, in my long career, I had colleagues who prioritize the weaker students, and because they're good-hearted, but it should not be at the expense of the strong students. We have to deal with the whole spectrum. One way to do that is to work at many levels. When I was a beginning teacher, I got the advice, aim to the middle. That was terrible advice. You have to sort of do the opposite. You have to aim for all the levels. I tried to do something too difficult every day so that nobody could feel like the class is not challenging, and something too easy every day so everybody can participate somehow, and then stop something, in the middle. So another way to think of it is the elevator has to stop on all the floors. So anyway, that's my Goldilocks strategy. Now, ways to do that, this business of going, hitting all the floors, addressing all the students is, there are two important ways to do that, which I'm not going to talk about today. One is discourse in the classroom. So having good classroom conversations, for example, number talks, or, any discussion where you involve the whole range of kids in discussing important mathematics. Important, but not today's topic. Another thing is rich problems and activities, formerly known as low threshold, high ceiling, currently known as low floor, high ceiling. Another phrase to describe such activities is group worthy. The activities are interesting enough for kids to work on in a group. And I think those are really important, but again, not today's topic. So a key approach I'm going to present, I'm going to present basically two big ideas. One big idea is extending exposure. The other big idea is a tool-rich pedagogy. So first, extending exposure. Pacing is kind of a key question, because you have the so-called hard teacher who just keeps forging ahead, and then you have the teacher who's so concerned about the kid who didn't get it that the class is kind of paralyzed. And I believe in embracing both of those ideas, rejecting neither. Constant forward motion. And we each have a preference. My personal tendency would be the constant forward motion. But I've learned that, in my years of teaching, that review is essential. So those two things have to go on at the same time. Constant forward motion on the one hand, eternal review on the other hand. I'm going to show you some ways to implement that. First way is what I call lagging homework. Let's say that I'm teaching a topic one, whatever that topic is, this week. I'm not going to give homework on it. We'll do it in class. Homework on it will be next week. So I've already stretched the exposure. I've doubled it. Instead of 1 week, it's now 2 weeks of exposure. First week, the kids are getting used to this concept in class. The second week, the kids are working on it. By then, hopefully, they can sort of do some of that on their own, so they're doing it in homework. But when that topic has become part of the homework, I can start a new topic, topic 2. And that's what's going to be going on in class mostly. So, but that's not the whole thing. I also will not quiz on this until week 3. And then in week 4, I ask the kids to turn in quiz corrections as homework. So now they have 4 weeks on this topic. This is a very, and this could have happened in 1 week or, a few days or a little more than a week, but I stretched it to 4 weeks. So it doesn't harm the strong students because we're moving on to new work, very soon. And it helps the weak students because they have time to learn it. In course evaluations, so many kids told me when they really finally nailed the concept was in sort of what on this screen is week 2 or week 4. It was crucial for many of my students to do the homework and then discuss it with their classmates, and then to see what they couldn't get on the quiz and then turn that in as homework. So anyway, so that's one way to stretch exposure. Another way to stretch exposure is to use cumulative tests and other assessments. Kids shouldn't feel like they shouldn't say something like, how long are we going to be doing logarithms? The kid who's asking that figures, okay, I'm not getting logarithms, but it'll be over soon, and hopefully I can get the next topic. And the cumulative tests, not every test, but periodically, and other assessments that you might assign to do at home, that again extends the exposure to ideas. Third way to extend exposure is not well known, but surprisingly powerful. It's to separate related topics. So for example, let's say you're teaching exponents, don't teach scientific notation right away. Put a few weeks in between and then teach scientific notation. When you teach scientific notation, you're reviewing exponents. Or, at my school we did, in trig, the tangent ratio in the fall, weeks pass, sine and cosine in the spring, which involves some homework reviewing the tangent ratio. So the tradition and an actual tendency is to go the other way. We just did proportional relationships. This would be a good time to do dilation because it's related. So the kids still know it. But if kids are only going to know something for such a short time, why are we teaching it? On the other hand, if you separate it, you're providing the review for the kid who needs it when you get the second time around, and you're extending the exposure. That's another way you're extending the exposure to the original ideas. So anyway, separate related topics. And I know that's a little harder to implement because textbooks aren't written that way and so on. But I did this for decades. It works really well. And then finally, make support available outside of class. I mean, I think, if you're doing, all the things that I've talked about, plus group work and so on, if you do all of that, you're going to reach way more kids, but probably not everybody. So some kind of support outside of class is needed and should be organized. At my school, we arranged a system where one of the math teachers was available during our lunch period every day. We took turns. And it was a pain in the neck. On the other hand, it was a place kids could go to. It was you could send kids to it. And it saved you from having to arrange special meetings with kids. They could go to what we call math cafe and get help from the math teacher. So these are structural strategies that you can, however you teach now, you can still teach the same way. I'm not advocating. I think we should all grow and learn and change our teaching over the years as we get better at it. But whatever you're doing, if you do this, if you follow these 4 techniques, it doesn't take more time. Like we're just rearranging the time. Like when I say lag homework, or when I say separate related topics, this doesn't take more time. It just rearranges the time. And the message to kids is, if you don't get it, you still have a chance to get. You don't get it now, you still have a chance to get it. What's fashionably known as growth mindset. But just telling kids you can grow your brain is not as effective as giving them an opportunity to grow their brain. And giving them that opportunity, these techniques, are a way to do that. Giving them the time that they need. Okay. So these techniques are important and helpful and easy to implement. Believe me, this is not hard to implement. This, you can just decide to do it. Unfortunately, it's not enough. So now I'm going to go to my second half of my presentation, a tool-rich pedagogy. And I'm going to sort of go through, basically I'm talking about learning tools. And I'm going to go through many, many learning tools. I'm not going to dwell on any of them. You can sort of research them in a deeper way by going to my website, where there's plenty of information on each. So, a tool-rich pedagogy, one sort of tool is manipulatives. So here are some examples. These are pattern blocks, very widespread in elementary school, not so much in middle and high school. I always open my geometry class, so 9th and 10th graders, with pattern block activities at the very beginning. And so I had these students who like trying to look as adult as they can because they're in high school now. And, they're like, wearing makeup and, heels and so on. And then they see these blocks and they go, yay, kindergarten blocks. And basically you're giving them a chance to relax in math class. And so this is a simple use of these pattern blocks to learn about angles. But then here's the more sophisticated use of the pattern blocks. This is an arrangement, sort of a tessellation using pattern blocks. That's part of a trigonometry lesson. This here in the middle is a regular dodecagon. And I have a trig lesson, which is what would, if there was a pi, like pi r squared, if there was a pi for regular polygons, what would it be for a square? What would it be for an equilateral triangle, regular hexagon, and so on? And it turns out that the pi, if the area of a dodecagon was pi r squared, a different pi from the usual pi, it would be exactly 3. Anyway, you can show this using pattern blocks. But it's part of a trig lesson, because to solve this in general, you need right triangle trig. So here are pentominoes. That's a kind of geometric puzzle. And so here's one of the pentominoes. And here it is with the dimensions doubled. This is 1 inch. This here is 2 inches. But what's weird is that when I doubled the dimensions, I ended up needing 4 pentominoes. They all have the same area. They all have area 5. So I doubled the dimension, but I multiplied the area by 4. For some reason, it's a really hard idea for students. So we solve a lot of these, puzzles like this, where we double and triple the dimensions. The kids solve them, color their solutions. We put them up on the bulletin board, and we have that as a reference. So when a kid makes a mistake, I can just point to the bulletin board to remind them what's going on. The ratio of area is the square of the scaling factor. Okay, well, so that's a good early lesson. But now here's a later lesson. These all have area 2. They're called supertangrams. And so here's this one here, and then at different scales. And so this takes 1, then 2, and then 4 blocks to cover. So from here to here, I multiply the area by 4. So that means I double, like this, my 1 inch here becomes 2 inches here. Well, what happened here? If the area was double, what was the scaling factor? Important discussion, and we can, about square root of 2, which is the scaling factor in this case. And so, and then what would this be? What would this be? So again, we had a more basic lesson using manipulatives, and here's a more advanced lesson, really along the same lines. Or here, this is algebra manipulatives, in this case, the lab gear. Make a rectangle with these blocks. Every kid knows what you mean, but you make the rectangle and you look at the dimensions. Now, a beginner in algebra, 2x, x plus 2, x squared, there's all kind of, there's a 2 and there's an x. But they work with these for a while, and clearly 2x is like 2 x's. X plus 2 is different. It's an x and 2 1s. And then x squared is actually a square. So at the entry level for algebra, this can be very powerful. But then here's an advanced lesson using the same format, basically. I made rectangles, x squared plus 8x made into a rectangle, x squared plus 8x plus 7 made into a rectangle. And that's really factoring this and seeing that it's x plus 7 times x plus 1, and so on. X plus 6 times x plus 2. All of those are x squared plus 8x's plus something. Okay, well then I try to rearrange them into a square. Only this one, I only succeeded with this one. These were missing something from being a complete square. And then here are the graphs for each of these. Going back and forth between the graph, the blocks arranged this way, the blocks arranged that way. There are a lot of connections. What are, how do the intercepts, the x-intercepts show up with the blocks? How does the vertex show up with the blocks? How does the y-intercept show up with the blocks? Useful and important conversations. But again, an advanced use of manipulatives. Or this lesson, which is now fairly widespread, you make squares on a geoboard, find their area. So this is tilted so you can't tell they're squares, but this is, this is a square, and then there's a square within it. And the outer square is easy to find the area. It's 1, 2, 3, 4, 5, 6 by 6, it's 36. And then we subtract the triangles to get the area of the inner square. Well, you do this a bunch of times with actual squares on a geoboard and do this calculation over and over. And what you're telling the kids is, let's find every possible square on a geoboard, every size, every possible size. You do this a bunch of times, and then you can easily follow the argument with A and B and prove the Pythagorean theorem. This is a standard proof of the Pythagorean theorem, but I used to tell kids that, and they would nod and act as if they knew what I was talking about. Now they all get it because they've done this a bunch of times physically on a physical geoboard, and they've done the calculation with actual numbers. So they know what I'm saying when I say A and B and so on. Okay, so that was manipulatives. Another kind of tool is technology. And I think there are 3 levels. It can help us to make things visual, can help us make things interactive, and it can help make things creative. So those are 3 levels of using technology in the classroom. So visual. Here's an important algebra, sort of late algebra 1, or in my teaching was algebra 2 topic, which is completing the square, which we already saw with the blocks, but here it is in a technological version. This square here has area x squared. I don't know if you can see, but this is x by x. And this rectangle is area bx. Okay, so now let's see what happens. So what happened is that to make a square, what I needed to do was divide this bx in two equal pieces, and then complete the square here. That basically is a visual support for the concept of completing the square, which is very hard to get if you just look at A, B, and C's on paper. So that's one way to make things visual. Here's an activity. Look over here. This is the volume, and it doesn't change when I move the top, but it does change when I move the base or when I raise or lower the top. So where I am up here doesn't matter. It's the height that counts, the height being the distance between these 2 planes. So this is a way to get the point across that it's the base, the triangle at the base, and the height, and kids can sort of interact with this. But then we're not done, because now we'd like to prove what the formula is. And to do that, we're going to divide a prism into 3 of these pyramids, and then find that the volume of the pyramid is 1/3 of the prism. And having the ability to manipulate this allows kids to understand how this proof works. So this is still part of making things interactive. Or this is my most popular creation. Kids are asked to graph this using an electronic grapher. So this activity has been done from the earliest versions to people doing it now in Desmos. From the earliest graphing calculators to people doing it now in Desmos. Make these designs. Very powerful lesson that makes the math interactive. The kid can choose which one they want to work on first, and then try and create that design using y equals mx plus b. It's a much more powerful lesson than me telling them something which they wouldn't hear, or even with me saying, graph y equals x, y equals 2x, y equals 3x, what do you notice? Because they may not notice what I'm interested in. They might say, oh, the line is getting more jagged. Doing it this way, they are coming up with the formulas, and they may be trying for this one and getting part of this one or whatever, and they can sort of correct their own mistake because it's interactive. So anyway, technology can be used to make things interactive and can make things creative. Look at this. Just give them a blank GeoGebra, let them get, initially just make whatever you want. So here's a design a kid could make, not too hard to make. And they can come up with their own ideas. They become obsessed with the colors and so on and so forth. Good introduction. But then, I'm going to show you an activity that was kind of later on in my construction unit. Here's the challenge. So by now, the kids have had a lot of experience with the geometric construction on the computer, and they have to construct a circle through this point over here, to ignore this pointer. They have to construct circles through this point tangent to this line. In other words, they have to do this. So this is the goal. So here's one way. I mean, after much struggling, somebody comes up with a strategy, and here's one strategy to do that. Perpendicular to the line, perpendicular bisector to that segment, at the intersection is the center of my circle. To test whether I got it right, I move this point, and I see that the circle continues to be through that point, and still tangent. So I did it correctly. But notice that the center of the circle was traveling along this curve. What is this curve? Well, it's a parabola because it's points that are equidistant from a focus and a directrix. So again, end of a unit of, sort of a challenging problem at the end of a unit that looks forward to a pre-calculus topic of, geometric definition of the parabola. So what I keep doing is showing you how the same tools can be used in an introductory way and in an advanced way. The tool approach should not be seen as remedial. It should be seen as good for the whole class. Now, some schools can, try and prevent kids from using technology. They say, well, if they use a calculator, then it'll be a crutch. And to be honest, that's okay with me. There are times where I said no calculator for this activity or for this quiz or whatever, but typically the default is use technology if it's going to help you. If somebody has a broken leg, let them use a crutch. Anyway, so, and this isn't to say that manipulatives and technology are the only tools. There are some, I'm going to show you some other tools that are useful in teaching secondary math. This here is a function diagram. So a way to represent functions, we always, we represent them in table, in a graph, and these two are of course super important, but this is a good addition to our tools. So the point 2, 1, order pair 2, 1 can be shown here, and it can be shown this way. Here's my X and my Y axes, and this time they're parallel, not perpendicular. Turns out this is a really good environment to learn many, many ideas, and you can go find out about this on my website, all the way from basic rules about signed numbers, all the way to the chain rule in calculus. So anyway, another non-manipulative, or maybe it's manipulative to some extent, is the 10 centimeter circle. And you can download these and print as many as you want. The 10 centimeter circle, basically it's a kind of a protractor, and it has centimeter markings along these lines. And so, for example, here's an angle with a positive x-axis, and that would be 10, 20. That's a 30-degree angle. And what is its sine? Well, it's 10 centimeters, so it's 5 over 10, because this is 10 centimeters. So anyway, so it's a tool to introduce basic trig ideas. You can see your right triangle trig 2 ways, like for example, this triangle, or this bigger triangle. And you can also see unit circle, except not a unit circle, it's a 10 unit circle, but easy to get from there to the unit circle. So anyway, very powerful tool to introduce basic trig. So all of this, all of the underlying concept underlying the tool-rich pedagogy approach is that it gives us ways to have multiple representations of the same idea. So if something is important, don't fool yourself into thinking that you just explain it the best way. People are always saying, well, what's the best way? There's no best way. Maybe the best way for this kid, but not that kid. But if something is important, teach it many ways. So, numbers, symbols, graphs, geometric, I highlighted this one because it's not done very much. Applied, real world so-called examples and so on. Because when you have multiple representations, it's many entry points. So the kid who doesn't get it one way may get it the next way. So a way to preview or review concepts. There's nothing more deadly than reviewing something the same way you taught it the first time. The kids who get it find it really boring. The kids who don't get it will say, well, I don't get that. But if you present it differently, you have all these multiple representations for the ideas, then you have a chance. And it's a way to extend exposure, as we talked about. And I mean, it's another way than the ways that I presented in the first half to extend exposure. It's a way to deepen understanding, because that's the difference between an expert and a beginner. Beginner, gets to how they can do something one way. An expert has many ways. That's why we're teachers. Kid doesn't get it this way, we try that way. So multiple representation is a key part of understanding. And it increases variety. So I always tell the story of I was in my first or second year of teaching high school. And so this is algebra. And like on day 2 or something, first week anyway, this girl comes up to me at the end of class and says, is every day going to be like this? My heart sank because, well, yeah, that's all I knew at the time. Every day was going to be me explaining something and then practicing in silence. And, using all these tools is a way to increase variety. Totally worth it. Kids like routine, but they also like variety. Math should not be the same from one day to the next. And, you use many tools, more motivation, it's more fun, it's more interesting, it's more stimulating. It lowers the threshold, there's more access to more kids. It raises the ceiling. Each of the things I showed include some pretty substantial challenges. And it's for everybody. It's deeper understanding for all the students. So, but I should warn you, unlike what I believed when I was a young teacher, tools are not magic. Just because a kid figures something out, say with blocks, it doesn't mean it's going to transfer, or it doesn't mean it's going to stick. It's just a tool. And we need, as teachers, to make sure there's adequate conversation, adequate review, adequate writing, adequate reflection, and so on. I mean, these are just things to add to your repertoire. They are not intended to replace everything you're doing. They're just something, extra choices you have in your teaching. And then I'm just going to throw in one last thought, which is to do everything I'm suggesting. The stuff the extending exposure ideas I presented first, those don't take more time. But the tool-rich approach does take more time. So to do that, it pretty much forces you to cover fewer topics. And I know that that may not be an option because you have to cover whatever the standards are. True, but I'll say 2 things. One is you can prioritize some concepts, some standards, and deprioritize some, so that the important things that are foundational, that affect everything, get more attention. And the things that maybe only a few kids are going to get and are more isolated, are not connected with so many things, those things can take less focus and less time. So in order to create time for the important topics. So anyway, that's the end of my presentation. I'm happy to answer questions, but before I do, I just want to advertise myself. I'm doing some summer workshops, and you can find out about them on my website. So this is in August, and one is a basic, called Visual Algebra, grades 7 to 11. The other is No Limits, which is Algebra 2, Trig, and Pre-Calculus. Anyway, and again, where you can find all this stuff is on my website with tons of links. Feel free to email me. And in fact, I'm going to show you where it is on my website, and then we can, I'm happy to answer questions. So this is the front page of my website. If you click on my talks, see the talk balloon, Cleverhead. So here, that takes you to reaching the full, and this is all my talks, but reaching the full range, these are all the links to the various things I talked about. And I'll add a recording of this webinar here. I already have two recordings, there will be more, there'll be one more. So, okay, so I'm happy to answer questions,
Okay. Henry, my suggestion is that people now can get on video. And and ask questions.
Okay.
Henri, can I?
Sorry.
Henri, hi. Can you hear me, Rule Smith?
Yes, I hear you.
Oh, very good. Can I ask a general question? I find that an issue for me in my teaching career has always been finding information. You know, it's hard, you know, organization is a problem. For example, like if you go on the website for GeoGebra, a lot of people have contributed different wonderful applications, but you know, you see 600 things that are about the same. It's very hard to find what you're looking for. But I'll take this back, not to GeoGebra, but really about NCTM. I mean, I became aware of this website through the new, I forget what it's called, but the forum that.
Yeah, my NCTM.
Yeah, and my thinking is this going to be on NCTM website in some way? So in other words, if I wanted to find some information about whatever, the major sort of, I guess, links that you would consider to this webinar, would I be able to access this webinar and essentially the, you know, the screens, the PowerPoint through NCTM?
Well, I could look into putting that up there, but I can certainly easily put a link to to my own website where there's a ton.
Right.
That would be easy to do, and I'm happy to do that. But you're asking. I mean, basically, what happened in the past few years, which has been a big problem for NCTM, is that there's a huge, massive amount of information available online, and the idea of one place being where you can find stuff, it no longer works. It used to be the way to find stuff is you would go to an NCTM meeting, you know, that was kind of, and you would read the NCTM publication. That's no longer the case. There's just massive amounts of stuff. What I learned in the past few years is that one way to do this, I'm not saying this is right for everybody, but it works for many people, is you get on Twitter and you follow people, you know, who are involved in math education, and then you have a question. You say, I need something for completing the square. You tweet, and then somebody's going to answer and say, oh, go to Henri Picciotto's site. He has some good stuff on completing the square, or whatever. You know, I mean, so that's one way to kind of narrow the search. There must be others, but I don't know of a good jumping off point to everything. It could be that NCTM hopes to become that, because as their other approaches have lost steam, they're really deep in that, and they're trying to figure out new ways to be useful. And so maybe my NCTM site can move in that direction of being a good resource. I hope that works, because that would make it easy for people to find things. But there's no guarantee, I'm afraid.
Thanks.
So any other questions about some of the things I shared? Well, apparently not.
Henri, can I ask another question then? I didn't want to, can I jump in again?
Fine with me.
It's about, you know, NCTM. Again, that I'm glad you also think that maybe NCTM is moving that direction, because I really think that, you know, if NCTM sort of had a position of culling the best. In other words, if you know, your webinar was sort of promoted by NCTM, and